Okay. All right. Thank you. So I think with that we can get started. So one suggestion before we get started is that we should keep the presentations very short, 3 minutes if possible, so that we can get time for questions and answers from the rest of the participants. So if you can keep your presentations short, that would be really much appreciated. Okay. So can we check to see that I'm gonna do a quick roll call to see if everybody's here. So is Tomohiro, Jonan Tomohiro from BitBips here? Yes, I see him here. Okay, thank you. Numada Sensei is also here. Mr. Numada, Professor Numada. Is Professor Numada here?
参加者リストは野原先生はいらっしゃいます。野原先生よろしくお願いします。
お願いします。
Okay. Okay. Spyros and Athanasiadis.
Hi, good morning. Yes, I'm here. Spyros Athanasiadis.
Thank you. Norman Carroll is also here.
Yes, good morning.
So is Rosen Mereshal here too?
Yes, good morning, everyone.
You, George Bostras here? George Bostras? No? Okay. So Deborah is not here, but we have Norman Carroll. I'm sorry, Norman Carroll is from Ingenious. Is Deborah here? Giancarlo Mariafiotti?
Yes, I'm here. Hello.
And Jorge Alfonso Curano is here?
Yes, I'm here.
Okay, thank you. So I guess we can get started, Fabio. So I'll give the floor to you.
Okay. Yeah. Well, welcome to this panel. And I think we will have the possibility today to address a very important pending issue for give a future to all our research. And this pending issue is related to a process that starts with the validation of technology proposed and go through their certification and finally to be ready for the adoption by first responders. So I hope we will have a very fruitful section. I'm pretty sure of that because having a look to the list of the participants, this is really very, very challenging. So I would like to start with Professor Mr. Jonan, Tomohiro Jonan, who is developing an application for improving the disaster preparedness for communities. And this is really something very, very important because we learned that it is impossible to face disasters without the participation of the community. And I would like to ask him what are the challenges that they are facing in terms of validating the technologies they are going to be used, and what are the policy restrictions and how to deal with personal data, mainly during simulation, because during emergencies, this is a minor issue. Please, Mr. Jonan. Hello, Mr. Tomohiro Jonan.
はい。もう大丈夫でしょうか。
Can I start?
簡単
Okay. So let me quickly introduce myself. I am Jonan from BitPeeps. I was involved in establishing a system to send information related to disaster to people. And what we provide is like this. So when facilities are involved in disaster, the members of staff need to have a lot of actions to take, because they not only have their employees, but also customers in their facilities. So they need to try and make those customers evacuate quickly. But to do so, we have to train members of staff and new starters as well. And there's lack of resources at night time, because disaster can occur at night. And even if you're trained in advance, you may not be able to take adequate actions. And then sometimes some people just get in panic. And so the problem here is whether the members of staff can persuade the customers to evacuate quickly, and also whether they can evacuate quickly enough. And here is the solution that we provide. So once disaster is detected, we get the information. So we receive meteorological data as in a form of push notification. And we provide such information using images and easy to understand text. And so we can understand the status, and it also provides you with checklist as to what needs to be done in multiple languages. And so we use easy to understand displays using audios and images. And smartphone is now widely available, and more than 80% people have smartphones. So that can be used during the disaster as well. And if we use app UI designs, and even the elderly people who are normally not so used to using smartphone can use these services. So we'd like to try and expand our services even more going forward. So that's all from me. Thank you.
Okay, thank you very much, Mr. Jonan. It is very, very interesting to have this point about checklists, because I think they are very simple, but there is a problem of communication, and I think you are trying to face that in a good way. Thanks a lot. I will pass now the floor to Professor Chierino Yuri, and I would like to ask him about how to deal with different information, some of them fake or distorted, that are circulating when there is a disaster around. And I think the issue of the validation of those information is very crucial. And I would like to ask him how you deal with the validation and certification of tools and information. Please. Yuri? Hello? We cannot hear. I cannot hear. Is it my fault or all the other people are in the same position?
The same here once you only the screen without.
ごめんなさい。ごめんなさい。すみません。今聞こえますか？
Sorry, can everyone hear me?
Yeah, now yes.
はい、では、始めます。すみません。パソコンをちょっと。
Let me start. I had to swap from one laptop to another. Let me give you a presentation in Japanese. And what I do is to have multiple devices connected in a safe manner, and that's why we came with this system. And this is, we use distributed ledger technology to create this system. So for example, blockchain, Bitcoin, which you're all familiar with, I'm sure. And if we were to use this technology, even hacker wouldn't be able to enter our system. And this system have real-time element, which normally takes a long time with blockchain. But we managed to create this system that allow us to write information in real time safely. And we get video data from drones. And we can retrieve that data in real time in a very secure way, so only those involved can receive such information. And all the data coming in will process using a system called Engu and send out required information like this. So we can send information to fast responders using wearables, etc. And we can make sure the information has never been tampered. We can guarantee that by using this system. And so anyone not involved in these activities would ever be able to access the information. So this is what a system called Engu is responsible for. And so this system allows us to guarantee the system, the information contained is reliable. That's all. Thank you.
Okay, thank you, Professor Tirino. I think you addressed a very important issue. I think one of the main challenges is the standardization. So the certification is really a key point to go ahead in the direction you propose. I would like now to pass the floor to Professor Numada in order to ask him to talk about the disaster response processes and how to deal with them. Thanks.
Okay, thank you very much for the introduction. So, I don't know, I prepared the Japanese, but better to speak in Japanese? OK、じゃあ、I will speak Japanese。日本語でいきます。災害対応の、プロセス。
Okay. Regarding the process approach to disaster management. This is my first time to appear, so I'll just introduce myself. I work with disaster management, disaster prevention, earthquakes, and so on. I go to... Sorry, it's breaking up. I go to the actual disaster area and assist with management of teams and disaster response efforts. And I'm trying to make a consistent approach for disaster management. Sorry, it's breaking up again. Sorry, there's an internet problem. I am not. This is a JICA project, a Japanese government-related organization. In the bottom map, you can see the PDA, the maximum acceleration, and you can see where an earthquake is going to appear as a prediction, or it can be actual real-time information. If you know the vibrations of the earthquake, you can also predict what kind of impact it will have. And you can see a particular town is expected to have a great disaster, and you can look at the predicted deaths, number of people to be evacuated, number of people that might be injured, and so on. Sorry, the internet's breaking up again. I'm not receiving any audio. So we can calculate the expected impact. So in Japan, disaster response usually has a set process depending on which type of disaster it is. This is an example from Kawasaki City at an evacuation center. And the process is all fixed, predetermined. Again, sorry, the internet is breaking up. I'm sorry, I think Numada-san, I think the presenter may have dropped out. Perhaps we should move on to a different presenter and come back to him. Would that be possible?
Yeah. I think
Thank you.
Right.
So can you send them a message? Or should I send them a message?
Let's see.
Is that him right now? Just doing somebody's thing.
Let me check.
I'm sorry,
Hello?
my internet is unstable.
No, I'm sorry, we were not able to hear you. I
Okay,
saw
sorry.
your presentation, and in the meantime, I downloaded your publication
Okay.
in order to have the possibility
Okay,
to
it
go
is
through
okay.
that. Okay, it is really very interesting, this process drawing, and I think we are using more or less the same approach when trying to simulate the process. One question that we will discuss later is how is the interaction between first responder acting in field and your simulation tool, because in our experimentation this is a little bit a weak point, because it is not so easy to have a debrief and collect information from first responder, because they are very busy and they cannot take care of giving us information. But you can answer later in the discussion about this point. Now I want to give the floor to Professor Hono. I don't know if I pronounce well, for the Tohoku University, talking about Hello.
Yes,
Hello.
my name is Kazunori Ono. I'm belong to the Tohoku University. But today I talk in Japanese.
Yeah. Thanks.
多分日本語で喋った方がいいですよね。さっきのやり取りを聞くと。これで画面見えていますか？
Hi. Are you able to see the screen?
Yes.
So we make cyber enhanced rescue canines. I say make, and I'll explain what that means. Our target is the kind of dogs that you can see in this video here, well-trained, clever dogs that can move with agility through debris and difficult situations. They bark to alert us that they have found a victim. The responders who are there with them, they want to know not just where they are, but the situation that someone is in. Are they alive? Are they dead? Are they injured? Are they stuck? And so on. The dogs cannot communicate this kind of detail. So that's why we developed the cyber rescue dogs. These are actually a sensor attached to the real dog, and it adds to the amount of information that can be collected by the dog. It's a system. This dog is an actual dog from the Japanese Association of Rescue Dogs. So we have useful figures, and we calculated this experiment. We use a GPS or microphone INU to send information. The handler is with the dog with a suit, and that sends out the GPS signal showing where they are located, where the dog is. You can see in the camera that the dog can find clothes which contain a human smell. It's a hat. And while the search is being carried out, a sensor is also working. When the dog barks, it records where the dog bark occurred. And then the team go and investigate that area where the bark occurred, and that allows rescues to happen. You can see in the video, this is the Japan Rescue Dog Association's tracking. This is the result. So it started where the start sign is, it runs up, it discovers a smell, it sniffs, there was no victim, it goes to the next location, sniffs, and the sniff points are marked. And then it found a victim at the top and alerted the handler to the location. And you can see what was in front of the dog at that time. It's grass and earth. So we know the victim is buried under earth and is not visible. With this information, the rescuers are able to take action. That's all from me for now.
Okay, Professor Ono, thank you very much. To be very honest, for me, the K9 experience also in the FASTER project was wonderful because we did some experiments in Spain, and I really like to run after dogs to see what they were doing in rescuing a person. So it's really something that is wonderful. I only want to tell you, if you compare or you discuss with our Greek partner developing the FASTER solution, and if there is the possibility to merge the outcomes in the future, that's something that we will discuss later in the discussion. So thanks a lot to all of you. Now we are going to switch to English. Thanks a lot. We are going to switch to English, and I would like to give the floor to Spiros Athanasiadis for the Ingenious project coming from the National Technical University of Athens. That is, he is going to talk again about the K9 and as an essential asset, and I really think this is very true. Well, I think also having a look to your visualization and the one from the FASTER and the one from the ONO solution, I think probably there is a need of a certification or a validation or let's say, creating a common view. Please, Spiros.
Okay, thank you, Fabio. Good morning, everyone. This is Spiros Athanasiadis from ICCS, a public scientific and technological institute, which is located in Athens. I would like to present one slide for the overall solution of Ingenious project, and after share 2 slides regarding our K9 vest. In Ingenious, we are developing, integrating, testing, deploying, demonstrate the next generation integrated toolkit for collaborative response, which ensures high level of protection and augmented operational capacity to respond to the disaster scheme. We have almost 20 different tools aiming to help first responders during their missions, and we have divided these tools in 3 categories. The first are the smart first responders that are mainly wearables and equipment for the first responders. And in this category, we have the K9 vest. We have the second category, smart devices in the air and on the ground. We have mainly drones, and Professor Norman will share an update regarding these tools after my presentation. And finally, we have a lot of, of course, a main platform, a COP platform, which integrates all the components, and a lot of mobile applications and backup services supporting all the tools in the field. Now, regarding our K9 solution, It is equipped with 2 cameras, a thermal camera and one high definition camera. We have a speaker and microphone for bidirectional communication between the dog and the handler. And also have a GPS system to know the location of the dog. And of course, all these subsystems are going to one main CPU, and through Wi-Fi communication, we can have all the data in the control center. Now, regarding our solutions, based on the feedback from the dog handlers and according to the terrains that we have to explore in the use cases that we have, our solution is modular. The cameras, the HD camera, the third camera can attach in back to the back of the vest with a stabilizer, so we can have a smooth video stream, or in the front of the dog, so breast without, of course, the stabilization module. According to the missions, to the rescue missions that we can have the vest with the cameras, without the cameras, and all the communication and the GPS signal. So one last point before starting the discussion is that our solution is modular, lightweight, and all the hardware, all the parts that we have in our solution can be replaced in the field in less than 2 minutes by the dog handler and continue the mission. So thank you, everyone.
Okay, thanks a lot, Spiros. It is very interesting, and this approach to have the possibility to exchange the module in field is something that I would like to know in the next section, when we are going to discuss about the ergonomy of that solution compared with the one, for instance, Ono, Professor Ono, and also the Univa are proposing, that is more, let's say, packed and not modular. So thanks again, and let's see what Norman Kerle would like to say about the work combining drone and artificial intelligence for a better situational awareness. But where we have to face, at least during simulation or exercises, the risk to infringe the privacy of people, and also the need for certification and the availability of the permission for flight during exercise. Please.
Thank you very much, Fabio. Can you hear me okay?
Yes.
That's very, very good. Thank you. Yeah, thanks for inviting me for this panel. I was asked to prepare just a few slides with a bit of background about myself, the university I represent, and our role in Ingenious. So let me share that briefly. I hope it's coming up. There you go. I hope you can you see my screen?
Yeah.
Good, excellent. So, yeah, my name is Norman Kerle. I'm a professor of remote sensing and disaster risk management at the University of Twente in the Netherlands. Background-wise, I come from geography, volcano, remote sensing, and my research for, let's say, the last 20 years or so has been focusing on disaster risk management, in particular post-disaster damage mapping, post-disaster recovery, using satellite data, drones, crowdsourcing, and other tools. Let me just point out at this moment here that within my faculty ITC at the University of Twente, we do focus on disaster risk management, and we have about 8 different chair groups in the disaster field. So it's a very diverse group of expertise or experts that we have here at the university, dealing with everything from hazard assessment, hazard modeling, risk assessment, resilience research, and so forth. So in my particular focus is on combining remote sensing and disaster risk management. So what we primarily work on, and also in Ingenious, is to use drone technology, and we try to develop procedures and, let's say, automated methods for damage identification. Now, this is in itself already a very complex topic. As you know, as we also heard before, when we talk about damage, we tend to think, let's say, almost exclusively about structural damage, as you see here. So broken buildings, debris piles, and so forth. And indeed, that is also what most of our work focuses on. But in let's say, in reality, damage, of course, goes much beyond that. It involves infrastructure, critical infrastructure, but also the parts that are not easily visible or cannot be seen in drones. So I think when you look at research trends, this is where developments are going to also incorporate, let's say, they're not immediately visible. So damage to economic systems, transport networks, and so forth. So, but for now, most of our work is indeed still focused on building damage identification, as you can see here. We try to work primarily with off-the-shelf commercial drones. As you see here, you know, the DJI drones. And the reason for that is that if you go back 10 years ago, so pre-DJI times, research groups would build their own proprietary systems, you know, developing all sorts of methods, but they were simply not accessible or available to first responders. The complexity of operating those systems was very, very large, etc. So we decided to use very basic, very simple tools, such as these drones that anybody can buy at a very low budget range. So we're talking 1,000 euro or something like that, or even less. And we focus on the data analysis side. So we develop machine learning methods. We work on 3D semantic scene understanding using the data that we get from these simple drones, rather than investing in developing our own hardware. So in the Ingenious project, we do focus not so much on the external mapping, and I do understand where the question of permission, etc., of course, comes from. And also in Ingenious, it does play a role, because one of our partners, the German Space Agency, is also working with a large drone that maps the outside area. But our work specifically focuses on taking drones indoors. And that's, of course, where the legal aspects are not so relevant. You can fly a drone within a building. The challenges are different, as I will show you. So we use UAV technology to map indoor spaces. We try to create 3D information of indoor spaces, and we try to perform semantic scene understanding of these indoor spaces, and we try to detect objects of interest. That can be damage, you know, collapsed walls, collapsed ceilings, but it can also be victim identification. We use drones that carry multiple sensors, and I'll show you one in a minute. So one of our Ingenious partners, FOI from Sweden, has been developing their own system, and now I sort of contradict myself a little bit. In this case, we're not using a commercial drone, but indeed it's one that FOI is building. But that has, as you can see here, various sensors, optical cameras, laser scanners, etc. And we also use quite the opposite, very, very small drones. And these are indeed, again, now commercial, weighing less than 30 grams, but that also carry a range of sensors, cameras, laser like a tiny laser pulse sensor in 4 directions, etc. And we do research trying to use these data, or to see actually which platform is ideally suited, for example, to help us map interior spaces, to provide first responders with actionable information. Where are the rooms, where are the obstacles, where are openings, for example. But as I said before, also where's damage, where are there, let's say, collapsed ceilings, collapsed walls, etc. So this is what our research work focuses on, but also here's an illustration of, let's say, a machine learning-based algorithm to identify victims. And here you can maybe even recognize some of these images. These are training images that we use to train our algorithm. They're not images that we created. You may recognize some from Bangladesh, factory collapse and so forth. So some pretty well-known images, but we use them to train our network. And as you can see, we can then use them to identify victims, for example, that are partly buried in debris. So this is what we focus on. Again, we are a research partner. We focus on let's say, research and development, on publications, etc. So if you're interested in any of this stuff, I would refer you to the profile here on ResearchGate, and I'll be happy to discuss any questions that might come up. Thank you very much.
Okay, thanks a lot, Norman. This is very interesting, mainly the fact that you are concentrated on indoor mapping. Again, I would like, well, the issue is then how to use those information in field, and this is something that is a common issue for all this technology. Thanks a lot. I would like to pass now the floor to Rosen Marechal, and from CS Group. CS Group is working in augmented reality and situational awareness solutions. I'm happy to work with some colleagues of Rosen, and she is going to talk about the certification procedure and the use of augmented reality, and how about the possibility to use holographic solutions.
Hello, everyone. Thank you. I will share my screen in a minute. So I hope you all see my screen properly. First, as an introduction about the Intrepid project and where the holographic hub stands. The Intrepid project aim is to develop an integrated platform that addresses all the needs of first responders during the early stages of a disaster, that is exploration, understanding, and decision support, mainly in urban settings. So we are developing a lot of tools to address all these needs from the ground down to the command centers, and one of these tools is holographic hub. So the concept of the holographic hub is to have a mixed reality-based rendering of the operation situation. That is, we are mixing virtual elements with reality, and here the virtual element is the virtual equivalent of the cardboard mock-up of the situation. You can see here, for instance, on the right, building represented on the table. Given its virtual nature, it can be navigated into, it can be manipulated, and also annotated by gestures by the user or the users of the COP device, of the AR device, sorry. As is a mock-up counterpart, it contains 3D model of the disaster area, but it also includes all the operation entities that may be relevant. And by entities, we are meaning, for instance, I would say physical elements such as first responders, agents. We are also meaning all the invisible elements such as incident position, threats. We can also display path or have ground annotations as used by the users. The design of the holographic hub in the scope of Intrepid, it's based on HoloLens, and it is centered around a BIM model representation of the area. The use of the BIM model as a center format enable advanced building feature annotation, since we can isolate each building feature, each building element. We can annotate them. We can also filter them to enhance the exploration capabilities of the disaster area and to improve the understanding of the situation. Of course, this scope is also in real-time communication with the whole operation management system. And by the whole operation management systems, I mean everything from the drone bound to the decision support. This allows to have a very up-to-date and complete situational rendering while in operation, but also coupled with the replay mode of the OMS, we can have an after action review capabilities of the situation in AR. Finally, a use case during which this holographic app can be used. It's meant to be a portable and up-to-date view of the situation for both command centers, but also for team leaders on the ground. It enables safe, realistic, and immersive remote exploration of the disaster area while keeping still a link with the reality around it. And it allows also cooperation between users, even remote users in different places, with a common visualization and common annotation of the operation theater. And that's all for me, and thank you for hearing me.
Okay, thanks a lot, Rosen. I had the chance to test one of your technology, the holographic representation, and that was very, very impressive. Okay, I think the use of BIM is for sure an advance because it is an accepted standard. So it should be in the future very easy to find those data available for each building. So thanks again. I would like to give the floor to George Boustras from the University of Cyprus. Well, and we are moving to the risk assessment, especially for fire. And I would like to know something about what is your opinion in terms of validating and certifying technology for having all what has been presented, for instance, today, but also in other opportunities to go really in the international market. Thanks. George, can you hear? Excuse me, Yasushi, is there any issue with George?
Can you say that again, please, Fabio? The issue with who?
Yes, we have issue with George Boustras.
George Boustras, when I did roll call earlier, he wasn't present. So maybe he's not coming.
Okay, so we skip him and we go directly to Giancarlo Marafiotti from the Cursor project. And I think this is something interesting because Giancarlo is going to talk about pre-standardization activity. And I would like to ask him if he can give us some information about those activities and how they can really drive all our solution to the market through a common certification.
Hello, everyone. Thank you for the invitation. So since this is the first time I'm joining this type of event, I would like to introduce quickly myself. And then I will try to explain what we're doing in the Cursor, giving this example that as Fabio suggested. So I'm a senior researcher at SINTEF, and I'm originally from Italy, but I took my master degree in computer science engineer there a long time ago. And then I moved to Norway, where I took my PhD in engineering cybernetics. And in the last years, my main areas of expertise and research are basically robotics for search and rescue, system integration, mathematical modeling, and control theory. And I've been involved in a few European projects with this, working in this area. But today I would like to tell you quickly an example of one of the tools we are developing in Cursor together with our partners. And in the specific, we are going to see what we are building as for this, what we call SMURF, that are soft miniaturized underground robotic funders, but they are basically small robots that are meant to assist the first responders in the search phase. This is a very simple illustration to tell you that SMURFs are these robots that you see on the right upper corner, and they have several sensors, so, such as the video cameras, thermal cameras, audio communication systems, but also some chemical sensing platform, as we call it sniffer. And in addition, we have communication and localization systems. The SMURFs are designed to be developed in the area where it's dangerous for human first responders or canine units to access. As you can see here, the SMURF can be carried by what we call transport drone. They are able to fall from 1.8 meters and work anyway. And then the main goal is to search and sniff out victims inside the debris. We are not working only with one robot. There's quite small robots, but we are working with a swarm of SMURFs because the idea is to have many of them deployed on the rubble pile, on the cone or inside. And then they are connected all together with the mesh Wi-Fi communication network, because communication is very challenging in this type of field. And in addition, we measure the position of each one of the SMURF by using a real-time localization system. And the position is important because if a SMURF detects a victim, then this information can be relayed to the first responders. As you can see in this short video, we've been running together with our partners, Tohoku University, and with the support from the International Rescue System Institute in Japan, some standard test methods for evaluating emergency response robot capabilities. In this specific example, you see the standard test for going over some gaps. Then in the project, we moved to the field. And in September 2021, finally, we managed to meet technical partners and first responders in the field in France, where we are testing the actual developments. For instance, you see here, we are starting some autonomous movement inside the tunnel. And then we are trying to enter a small hole inside between concrete slabs. And this was the first time in the project that we met and tried to test our prototype. And you see some user interface. You see that we are now racing the robot and using the infrared camera, for instance, to detect some parts of the victim. And also we are doing some drop tests here. But this is a way for us to validate our technology in the field. But working in the project, we realized that this is not enough. And also this hopefully will help starting the discussion with all of you today, because technology, we are working on prototypes, but I mean, eventually we want to go to the market, and our technology must be certified for the field. And then initiative taken at the Cursor project with several partners is we started this called the SEN Workshop Initiative, that is basically a way of starting a pre-standardization activity. And then our main goal is to produce a guideline for the application of a test method for innovative technology to detect victims in debris. And this ends my presentation, and I would like to thank all of you for the attention, and also the large team working on the SMURF, but also the other partners working in the Cursor project.
Okay, thanks a lot, Giancarlo. I think this is very, very challenging, and I hope we will go ahead in this opportunity to find the right certification and also a common validation for first responder of the technology side, such as SMART. Thanks again.
Thank you.
I would like now to leave the floor to, I don't know if Alfonso Curano is here.
Yep.
I would like to, okay, I would like to give the floor to you. And well, I think your interest in the augmentation of human senses is very interesting in order to give first responder more safety during their work, and the use of artificial technology is really very, very challenging. The point is that every time the same when we talk about artificial intelligence is, well, how you are going to validate and if there are, I don't know if you are prepared for that, but if there are implications for the privacy when using those kind of technology. But this is not a question for you. This is more a question for me because I am dealing with that in projects. Please.
We are also dealing with that in ours as well. So yeah. Okay. Thank you very much. Thank you very much. Let me share my screen. All right. So, okay. I don't know what you're seeing. Can you see the presentation? All right. So just a few words about me. So I'm Jorge Alfonso Curano. I'm a telecommunications engineer by the Universidad Politécnica de Madrid. And I've been working in national and international projects since 2006. So my initial area of expertise, or my first relation with the project was with the ITS, the Intelligent Transport System. So I'm more aware of what's happening with transport and mobility. But of course, in all these projects related to mobility, it's inevitable and unavoidable that you have to interact sometimes with emergency services and first responders, because of the use cases were probably related with assistance in traffic accidents and dealing with incidents in the roads and so on. I have also been since the beginning involved in projects that are more directly related with the area of emergencies as first responders, such as the one of police enforcement several years ago, and more recently one joint project that was called also Rescue, which is also the one that I'm going to talk about now, which was a joint effort between EU and Brazil. So about the Rescue project. As Fabio correctly said in the introduction, basically we're focusing on improving the tools that we can give to the first responder individuals to enhance its awareness, his or her awareness on the field, and also be able to work in a safer way. And we're working also, this is very important to understand how we focus the project in the specific assumption. It has been mentioned by some of the earlier speakers that communications are very challenging. So we are working on the assumption that the first responder individual is not going to be able to constantly communicate with the different partners in the team, with other team members, or even with the command and control. And not just communicating, but data exchanges are going to be difficult as well. So again, it's about reinforcing the tools that the first responder has in order to have a better awareness of the direct environment, and whenever possible, of course, being able to communicate and share the information that the first responder is collecting with the other teams. As I said, whenever possible. We're working on the assumption again that those communications will not be continuously available. So this is where it comes, the key of the thing that I that I want to talk about in this presentation, and that we're dealing with in the rescue project. So we're looking at, as I said, improving the perception of the first responders and improving in the wider sense of the word. So there are 3 ways that we have, or that we are exploring in the project of improving this perception. One is to provide the first responders with a clearer perception. This is perhaps the more traditional view, or the more traditional take on improving. So we're using artificial intelligence tools to provide enhanced direct vision, enhanced hearing, enhanced olfaction. So the idea will be always to, as I said, imagine the first responder is in a tunnel full of smoke, or in the middle of a storm in a mountain. So what we want is to be able to minimize the effect of those environmental circumstances in order to provide the first responder with the best vision possible given those circumstances. The same goes with the hearing. We have been talking with the first responders and the associations and partners, and they gave us clear guidelines or what they want to be able to hear in a clear way during the mission. And they told us, for example, they would like to hear the words coming from the team members better, or they want to hear if there's a sound that might suggest a dangerous situation for them or a potential hazard. They want to be able to clearly discern what is that. The same goes with the olfaction. That's the same idea. We're developing tools in order to improve the identification of what could be potentially dangerous gases or emissions or pollutions, lower or very high levels of oxygen that could point to fires or explosions nearby. So things like that. The same with self-positioning. So here, I believe what we're doing here is basically the same as those drones that were indoor mapping the environment. We're doing that with the first responders. So the first responders are equipped with a camera, and whenever possible, after making the image clear, for example, we can situate them inside a room, identify relevant elements in the room, and so on. The same applies to if they're in a tunnel or if they're anywhere. So all these tools that we're considering are about making the first responder individual have a better situational awareness of what's happening around in all the senses. So improve sensing. Besides the clear perception, what we can do is the wider perception. Of course, what you can see, what you can hear, what you can smell is limited, because we all have our own range, or there could be obstacles in the way, or there could be overwhelming circumstances. But maybe our teammate who is 3 meters ahead, or who is in the room besides, can also, given that he's also collecting his own information over his near environment, can enhance or make wider our view of this. Again, please don't forget that we talked that the communications between team members is not guaranteed. We're working on that assumption. So whenever possible, if we're close, if we can exchange that information, we will be doing that. So now we have an individual who doesn't rely just on his own senses, but also on the senses of the first responders or the team members that are around, and can communicate with this first responder. And another point that I think it was also mentioned in one of the presentations before, we can also make use of information that is stored in the building, in the black box, in the BIM. So whenever we pass by, or whenever a first responder pass by, that there could be an information exchange, for example, the layouts of the building or any other relevant information that could be done there. And finally, we have the clearer perception, we have the wider perception, and then we're talking about the adaptive perception. So what is the overall situation? Are there any dangers around? What is the status of each first responder? Am I in a very high stress situation? Am I under a very heavy cognitive load? Is there anything that I should be aware of that overrides basically everything else that I'm seeing myself? As I said, for example, there's one of my teammates in the room besides have detected that there is a potential explosion nearby, or the presence of dangerous gases. So that information should be relayed to me, and I should be able to work on that information or any other information that makes my performance during the mission the most adequate. So here what we're considering is not the outside environment of the first responder, but what is my own status as a first responder? What is my cognitive load? Am I stressed? Can I handle more information, for example, in order to provide support to other teams of the first responders or no? So this is another of the big tools that we're doing in the RESCUE. So the cognitive load assessment of each of the first responders and the prioritization of information that should be distributed to each of the first responders, considering not just the say objective situation in the field, but also my subjective cognitive status. And these are basically the three things that I wanted to comment and raise. Again, I think the approach that we're taking, focusing on the first responder, complements very well to most of the other initiatives that have been explained. And well, I would say that chances like this event of talking together could give rise to joint participation and collaboration, because frankly, I see a lot of ways we could complement each other. So yeah, thank you very much.
Thanks a lot, Jörg. I think what you did is very interesting because it's focused on the person. But it to me it will open an issue and a challenge. And the first one I would like to introduce as an open discussion, because we have very few minutes after the end of our slot. But I would like to introduce a discussion about the how we are moving toward the validation and standard like ISO or UNI or stuff like that. I would like to ask that to you, because you are addressing the human body, the person, a direct contact with that. But this is also something that is related, for instance, to communication, because we are today we saw so different and way to communicate. My fear is that I'm not sure they are following the same protocol and they are easily interoperable. So the first question, but the question is for everybody, not only for you, for sure. And I would like to for instance, to know what is the CS position, because they are working as you did with the BIM, and they have also a common operational dashboard, and I would like to know how it works. Please start you, and then I would like to listen Norman or Rosen from Rosen from Intrepid, and probably also Norman or Spiro.
All right, so thank you. So our take on this one is that well, our project is now in this 9th month, so we're currently working on actually defining all the data flows and precisely what needs to be done, what needs to be extracted from each of the tools. As far as we know, there is no standardized data set for that one. So we think that one of the outcomes that is going to be interesting to follow up from the RESCUE project is precisely that one. We have two elements in the solution, in the platform. One of them, we call it the orchestrator. The other one is the prioritization module. The orchestrator basically collects or aggregates all the information available, both at an individual level and whatever is available from other sources, and makes or builds an overall view of the situation. Again, around the first responder. This is not command and control level information. This is, again, individual first responder level information. As I said, we're on the way of defining precisely what information is first required by the first responders, And second, available or feasible to obtain and exchange in that sense. So I believe the data set that comes out of the definition of this orchestrator component is probably going to be one that we will definitely try to disseminate in terms of standards or to give it a more industrial foundation for that.
Okay, thanks a lot. I don't know if Rosen can say a word about that. If she's there.
Yes, I'm here.
Okay.
In the scope of, sorry, please.
Please.
I would say that in the scope of Intrepid, we are using the BIM model not for positioning because we don't consider it real. We don't consider it we consider a starting point because we are aware that during the operation the BIM will have to be updated. So we are not using it for positioning because positioning comes before updating the BIM model in the workflow. I don't know if I'm very clear. So these two approaches, in my opinion, are very complementary regarding the format that is used. We are more focused on the update of the model itself than on the initial model.
Okay. Well, anyhow, this BIM is going to be more and more quite a standard for, let's say, for official documentation of buildings and also for in cultural heritage for museum and stuff like that. So I think it could be great to use that as a starting point as you are doing. I would like thanks a lot for that. I would like to know from Norman if in doing the indoor mapping they are in a way following the BIM standard or they are still in the prototype phase.
Thanks, Fabio. Let me say a couple of things. And going back to your earlier question, I would also invite maybe later on Spiros to talk more about the standardization of the overall system, because as project coordinator, Spiros has a better overview of these almost 20 tools that he mentioned, how they get actually fed into the Fusion engine and to what extent standardization is being addressed there. In our indoor mapping, we are essentially dealing with situations where typically very little a priori information is available. Let's say the first responder gets called to a disaster scene. Typically, you do not have a lot of information about the, let's say, about the built environment. Where it does exist, it can be incorporated. Where BIM models exist, they can be incorporated. But we tend to focus on situations where, let's say, almost nothing is available. And precisely the point or the challenge of sending first responders into largely unknown and potentially hazardous environments is what drives us in this project. So having said that, the idea of sending in the drones rather than the first responder equipped with a lot of sensors is to investigate the environment in terms of its basic layout. What is the indoor space? Is it wide open? Is it narrow, etc.? What is the state in terms of its structural health? So as I said before, is the walls caved in? Is the ceiling caved in, for example? Are there heat sources in there that the first responder needs to know? So this is the type of information we want to make available to the incident command before they send or before they make a decision to send first responders inside. So with regard to your question, if information is available, such as a BIM model, it can be incorporated because we deal with a global, let's say, a coordinate system that fuses the information from our outside drone in terms of GPS coordinates, but also it translates all the interior coordinate system into that global coordinate system. So if you have a BIM model, for example, that can also be incorporated. But with regard to the question of standardization, I would refer you more to Spiros actually to comment.
Okay. Thank you, Norman. One comment also from my side. Also, the same applies with the GPS signal for the K9 Invest. And as I said in my presentation, we almost have 20 different type of tools in our toolkit. Almost every tools are developing according to standards in the specific area of the tool and the sensors that we have. Sorry, one last comment regarding the data model that we're following. All the information from the field are going to the Fusion engine, and the Fusion engine is, let's say, the middleware between the components, the sensors, from the field to the central application. And currently, we have decided to follow up a custom data model due to the reason that we have a lot of different type of tools, as Norman said, in our toolkit. Thank you very much.
Okay. Okay, thanks a lot. So coming to the second issue, so about the certification of what we are going to introduce for first responder, I saw that we have mainly, I would like to ask you, Spiros, due to our now online, about the K9 technology, and also to Professor Ono, if she's online, but I don't think so. If there is any kind of certification process that could be needed for the K9 adoption, technology adoption. I think we are running out of time, Yuri. Is that what you mean?
We can extend the meeting a few more minutes, maybe about 15 more minutes, to cover some of the questions. And I think I thought you said that Professor Ono was not online, but he is online. I can see him, just in case.
Okay, okay. So I'm very curious about these K9 technologies, and if they are going to be in a way adopted and certified by someone in order to be available for first responder. I asked Spiros, but also Ono, if they want to answer.
Okay, I will use only 2 minutes because we have a lot of time left. So regarding our validation and certification within Ingenious, we have a rich validation program with 3 rounds of laboratory integrated tests per tool, 2 rounds of small-scale field tests that are dedicated also per tool, and 2 full-scale exercises that we're going to have the whole toolkit. Currently, we have conducted 2 rounds of laboratory integrated tests for the K9 Invest, and 1 round of small-scale of tests. And the upcoming period, we're going to have the first full-scale exercise with all of the toolkit. Regarding the K9 Invest, given the fact that the dogs operating in restricted spaces, such as ruins, they cannot wear anything that extend out of the vest and might restrict their movement. So that's why we have designed a modular, let's say, subcomponents, and according to the missions that we have, we can select a compact solution with only the GPS and the bidirectional audio, or if you have a mission in a larger area, we can have also attach the stabilizer and the cameras. Thank you very much.
Okay, but I would like to know the position of Professor Onno, because they follow a different approach, not so modular, but very, if I saw well, the vest is completely different. Please. Professor Onno, can
は
you
い、
hear?
我々、はい、我々は、ベストっていうか、
So we create vest in the form of suit, but it was originally based on rescue robot. So all the components are moduled. So if camera is broken, we can replace it with another one quickly. And even GPS is broken, it can be replaced with a new one quickly. And what we do to make this available to users is the currently Japan Rescue Association and Japan Rescue Canine Associations, where we work with them, and we put our vest on rescue dogs, and we're trying and made suits that can be worn by rescue dogs for a long time. And the vest used to have various sensors sticking out, but when dogs are in contact with other objects, and it will easily come off. But we'll try and make sensors compact. And when there's the best is not well balanced and it can be inclined, but we'll try and modify the modules so that it's now well balanced, and we had good feedback as well. So we put our product on various rescue dogs from around the world, not just in Japan. That's what we did.
Okay. Thanks a lot. Thanks a lot. Is there any process for certification to be used by first responder in Japan?
日本で初期対応者が使う、プロセスは何かありますか？
いや、ないですね。日本は新しいテクノロジーを
No, not particularly. Japan is not particularly assertive with implementing new technology, so we don't have a particular process. Our suit, for example, the police tell us that they would love to use it, but the department in charge of procuring say, please use the existing items, and they don't approve the purchase of it. So there's not really a suitable system for our products to reach the users. That is an issue.
Yeah. Okay, thanks a lot. And I think more or less we have a similar situation also in Europe, Spiros. Okay, so I think I would like to ask Giancarlo and Rosen if for robots and for the COP, is there any expected standard or validation process to be used by first responders?
Okay, this is Giancarlo. As far as I know, there isn't a standard, and as a matter of fact, we've been discussing in Cursor project that something is needed, and that's why we started this CEN workshop agreement is called, where we are trying to understand how technology, and in this particular case of today's presentation, the robotic platforms can be used in the field. and by also used by the first responders. I can tell you that in the project, we have been working on evaluating all the current standards. For instance, we are using standards for communication that are well known worldwide. So our tools are trying to apply all the standards available, but we see there are holes in the certifications area. So there are no, as far as I know, no certification for robots or equipment or tools that can be used in the field, in particular for search and rescue tasks. I can tell you that, for instance, as an example, what we do is like look in other research in other areas, such as if you want to use robots or tools, equipment in the explosive environments, then you know that there is a ATEX certification. So whatever you build or you want to bring to the market, you know that it has to be certified with that type of certification. But this is not something we have in the search and rescue use case or area.
Okay.
So I have one comment for this application because how to say.
このアプリケーションについて一つコメントですが。
So they made some standard method to evaluate the mobility of robots. So they proposed such kind of method. So Professor Tadokoro, he is a collaborator with Adam J. Cole. He is a main person of the NIST standardization of the mobile robot. So maybe it can be used for evaluate the ability of the mobile robot. However, as you say, there is no rule to use the evaluation for the rescue tool. So maybe we need to find good solution about this topic. Thank you.
To comment on that, yeah, of course, this was in one of my slides. It was exactly the work done by Tohoku University and Professor Tadokoro and his team. So we do actually add some standard tests for mobility, for instance. But I'm referring more about certification more in general, like our tools that we've been seeing today. But that's a very good point.
Yeah, thank you.
Okay. So thanks a lot. I would like to say a few words to close this panel. It is clear that we have an impressive number of new technology available, both to act in facing the danger and the hazard, and on the other hand, to protect and to enhance the capability of first responder. There is for sure the need to go ahead in having clear standards and a common line to deploy all this technology in field. But I think the way is in a way tracked, and now it's only a matter to go ahead and to convince more and more first responders that the new technology are very important for them, for their safety and for their effectiveness. In my experience, the first responders are very conservative, but I can understand them because they are risking their life. So it is very important for them, first of all, to have their safety guarantee. So it is a way, not a long way, but it is a way we have to follow to go in that direction. I think the emergence of some standard, also talking about BIM, could help all of us because having let's say, detailed information in the beginning, not having to wait to be in the emergency place, to me is an added value. And we have to try to collect all this information and create a real integration between our new technologies and the existing data that could help and could shorten the process to answer the disaster. So thanks a lot to everybody. It was really very interesting for me. I have a paper full of annotation, and thanks a lot.
Thank you.
Thank you very much.
Thank you very much.
Thank you very much, everyone.
Thanks.
I'd just like to add a couple of comments at the end. Thank you very much, everybody, for joining. And we will have another session in about 45 minutes. This is intended for the European participants. It will be in English, and we'll have some very impassioned testimonials from practitioners. We'll have one from Japan, from Professor Murakami, from the Rikuzen Takata Agency. And we also have Roberto Cremonini from Regione Piemonte, Professor Duane Hagelgans from Millersville University in the United States, Dr. Julio Ruiz from Spain, and Haris Georgiou from Greece. This will be very interesting. We will broadcast this same session tomorrow in Japan, in Japanese as well. So if you want to hear in Japanese tomorrow for the Japanese participants, please participate tomorrow. If you want to hear them in English, they will be broadcasted in about 45 minutes. Thank you very much, everybody.
Thank you.
Thank you.
Bye-bye, everyone.
Thank you. Bye.